So in this session, we are going to talk about HBase attributes. What is the physical storage of HBase? We have seen some of that. Execute the commands on the shell. We have already done that, guys. Okay. Then analyzing the data loading techniques, implementing the API. I'll just touch base on that today. And then these three things we will be talking about. So let's move on. So if you look at HBase, what is it? It is simply a map with a key and a value. So you will have a key and you will have a value. Okay, that's what we are trying to convey to you over here. And the map is sorted. Remember I told you 3 levels of sorting. So the sorting happens at the column family, column, row, and the value. There are different levels of sorting. So if you look at the data coordinates what we have, this is what is the row ID. This is what is going to be the column family. This is what is going to be the column name. And then by default, there will be a timestamp and there will be the value for it. So if you want to access anything, you will have to go with the row key, column family, column, timestamp. So that is a way how you will be able to access a value. So the password, earlier we had a different password, and at a different time we had changed the password to something else. Okay, so these things we have already seen. So, but then it is good to put it onto a slide so that you will understand this and there is no confusion on it, folks. So, simplifying HBase. HBase is actually multi-dimensional columns. That means you will have multiple columns in a column family. So, foo and bar are columns of column family A. Okay, foo and bar are also called as column qualifiers. Okay, so just letting you know what is a column family and a column. Then timestamp is also, that means even the values are sorted in a descending fashion. You decide how many versions you want, and based on that, HBase will store those much number of versions for you. So if you look over here, this is what is the row ID, this is the column family, this is the column name, and these are the different values of for that particular column family, colon at a particular point of time. Okay, so if you look at row, column, and timestamp will return me M. So that means A, foo, and 4 will, that's the timestamp, will return me the value at that particular point of time. So if you look at the data model, you would see that table schema only defines the column families. We have actually done that in the hands-on. It will consist of any number of columns. So columns are added at the time when you add a record. It can consist of any number of versions depending upon what is the schema that you have specified. And columns are there only when something is inserted into it. You know that. So that is what is the Spark database. And columns in a family are sorted and stored together. Okay. So this is the data model that we have. So just to give you a different example, if you have got personal data and demographic data, you will see that name and address are there in personal data and birth date and gender are in demographic. You see that I don't have the address for D, Cooper and Merlin, but that's okay. That is what is the ability of sparse. Okay, so you can have any number of row keys and you can have any number of values for your personal data and demographic, which are column families. Now, how are they stored physically? Physically, they are stored in the form, every column family is stored physically, but then the thing that links the two column families is a row ID. So you can see for every row, there are some values in the form of a column in that column family section. And similarly, for family 2, for demographic, you have got the birth date, that is a column value. So this is how the physical storage would happen, friends. Now, how does it look like? You saw when I did a scan, it showed you the row, it showed you the column plus cell, and of course the value of it. So what is the row key? Row key is something that has to be unique. So it is very important that you should identify what is the row key of what you are going to store, because the most important is the row key is the way how you will be able to access that particular file. Then you will have column family colon the column qualifier, that is a column name. So less number of families gives faster access. Okay, families are fixed, whereas column names are not fixed. It is happening, it's going to happen at runtime. And there are various versions of the values that is maintained, and like what I had demoed it to you, scan will only show you the latest version of what we have. Now if you look at the copy link, friend, Dheeraj, can you look at the copy link and confirm to me if you're able to see everything? So if you look at the copy link of Edureka, you will see that in the HBase API, I have got a document called as transferring data to HBase using PIG. So it will give you an example of how to use PIG to transfer data. I've already copied HBase.xls over there also, and plus today also. And there is an HBase API, and inside that there is a Java file called as HBase test. That is something that we will be running today, and I'll be showing it to you. So programmatically we are going to do that, guys. Okay. So this is just to show you on the screen what we have done. Create, put. Okay, guys, tell me, what is this A, B, and C in this example? You see that there is an A, B, and a C. What is this A, B, and C? Are they versions? No, they are the column names. Versions would be separate values for the same column, right? They're not the versions, friend. They're actually the column name. That's correct, Srinivas. That's correct, Praveen. Okay? Cool. Now when I do a scan, what do I get? I get the complete list of values. So this week, please go ahead and try the hands-on what I have shown it to you, so that it will be easy for you. And then there are various APIs for get, for put, for scan, increment, check, put, delete, etc. There are various APIs. We are going to see an example of those APIs very soon. Now, from the programming perspective, okay, you are going to code in your Eclipse, which is there in the Edureka VM. So you would need all the jar files. So let me quickly go down and show you where the documentation is. So I'm going to go down to the VM, and let me scroll up. I don't need these windows. So let me close this browser completely. So that is taken care of. Now, if I go to one level up, okay, HBase section, if I go down to the docs folder, there is something called as API docs over here. So please remember, guys, there is a folder called as book, which will contain one of the best books that is there in HBase, that is the HBase reference guide. So you will have to have a look at the HBase reference guide so that your concepts become very clear, guys. So please have a look at this HBase reference guide. So I'm going to click on the book. I'm going to open up any of the HTML. Okay. If I open up the HTML, it will open up in the browser and show it to me. See over here, guys. And if you scroll down, you will see that there is something called as, let me scroll down completely. There will be something called as home. And if I click on this home, you will see that this is the HBase reference guide book that we have. Okay, so the whole book is available for you in case if you want to practice more. Okay, cool. Let me close this. Now I'm interested in the API. So if you look at the API docs, and I'm going to click on index.html, that will show me the documentation for this, friends. So let me open up the documentation. See over here, and if you look at the HBase client, you will see a class that we will use very commonly called as HTable. So what is HTable? HTable is used to connect to a single HBase table, and that's what I am showing it to you on the screen. So let me go back to the PDF. So you see over here, for using the HBase client API, you will use a class called as HTable. And we say that it is better to create a HTable instance only once and one per thread, and reuse that instance in the life cycle of your application. It is not advisable to create separate HTable instances every now and then, because it is going to be expensive. It's like a connection. So what all are the different ways how data can be put into HBase? One, we have already seen it using the shell, right? That is using the HBase shell. You can also use PIG. If you wanted to put data, there is a document that I have already shown it to you in the copy link, how to use PIG. You can also use Scoop. That's what we will be seeing next Saturday. And of course, you can use a Java code and you can use the client API. So we are going to see how to use the client API today. For you to just quickly have a look at the PIG part of the code. So let me quickly go down to HBase API and then click on this PDF link which you already have. Although this example is showing you in Cloudera, the same thing you can very easily do it in your Ubuntu VM, your Cloudera VM also. So see over here how we are creating a PIG script file. See here how we are going to use HBase. So try these examples, okay? These are very small examples that is there, and we are showing you how to create a table, and when we run the PIG script, you will see how the values will be automatically added. So please try out these examples. So now let's see how do we go about doing it. So if you talk about Scoop, okay, what is Scoop? Scoop is an import-export tool which is used for moving data between a relational data store and HDFS. Okay, so we can even put our relational data into HBase. But please remember, HBase data cannot be put back into relational because HBase is what? 2-dimensional or 3-dimensional? It is 3-dimensional. So you will not be in a position to put the 3-dimensional data back into a 2-dimensional RDBMS. But RDBMS data can be put across to your HBase. That is what is possible. You see here how we are going to use Scoop import. So import means pushing the data into HBase. So you will use your connection string, your username, your table to connect to HDFS, and then you will specify what is the HBase table that you want to put the data to, what is the column family, what is the row ID, and what is whether you want the table to be created or not. Okay? So this is the way how you will be able to use Scoop, my dear friends. Hey, Srinivas had a question. He said, Hive output will almost be structural. Why can't we load from load to Hive? Hey, Hive is for analytics, right? Hive is not for your real-time component. Hive is primarily for analysis. Make sense? So the output of an analysis, you can put it into HDFS and then you can put it into HBase. So whenever you want anything in real time, that is the time when we will be doing it. Hey, the reason why we can load from Hive to HBase is because it is by default Hive means the data is in HDFS, right? So I can directly do that. Make sense? So now the Java code that we are going to see, you will see that it has got configuration. So, you know, in your Mapreduce also we use configuration. Here we will use H configuration. Then we will use a class called as HBase admin, which will allow me to create a table dynamically. Then there will be a class called as HBase descriptor, which will give you the details of the table. And finally, there will be a H table, which is going to point to a single table. So using H table, you can either say get, put, scan, etc. All of those things you can do, guys. So we are going to use all of these things in one code. So let's go ahead and see the code. So this Zookeeper is something that we will see later on. So now I wanted to actually run the code and show you how that would happen. So let me go down to my Eclipse. So let me go down to my Edureka. Let me minimize my screen over here. Okay. Let me start with my Eclipse. Where is my Eclipse? There we go. So I'm starting with my Eclipse over here. While Eclipse is coming up, let me explain the code to you. Okay, so if you go down to your LMS folder, in the LMS folder there is HBase, and you would see that there is HBase Practicals Module 8, and there are two files what we have, HBase Test and HBase Connector. Okay, so HBase connector is a Java code wherein you are going to connect to a table which is already existing, that is called as my little HBase table and my little row. This we have taken it from the internet. We are specifying our family qualifier and some value, and we are showing that. So what is the prerequisite for this? I would expect that table to be created. Okay, so that's what I'm going to do now. So if I go down to my putty, okay, I'm going to create a table called as my little HBase table, and let me say create. I don't know why it is clicking so much. My little, I need to put it into a single quotes. Okay, my little HBase table. Okay, my little HBase table, comma, that is the table name, sorry, single quotes, comma, what is the column family that we have over here? That is called as my little family, that is the name of the family, and I'm going to say single quotes, my little family. Okay, and I press enter. So the table is created. If I say list, you will see that I have got a table that is already there. Now I can actually run this example. So let me go down to, let me close this code. Let me go ahead in Eclipse, and I would need to run this. So my Eclipse, I am saying okay. Here, let me have a look at the questions window. Srinivas was saying, after I do analytics, I get a condensed set of data in HDFS, which I wanted to show in RT onto a web page, and this keeps on happening periodically. So the output of Hive should be shown onto the web page via HBase. Is that possible? Very much it is possible. The only thing what am I saying is, why do you have to use your Hive to output the data to HDFS? From HDFS directly you can push it into HBase, and then you can do that. You can simply write a Java code which can read from the Hive table, and then, because Hive table means the data is HDFS, right? So from HDFS you will have to move it to HBase and then do that. Make sense, Srinivas? So now let me quickly go ahead and see if my table is there. Just give me 1 sec. So my first MR code is there. in.edureka. Sorry, this is word count testing. That's not what I want. I'm going to create a new package. Okay. So I will say file new Java project, and I'm going to call it as HBase examples. Okay. And I would say finish. It's done. Now I need to add my jar files, right? So let me add the jar files. Hey, you can definitely use a REST or a REST API on HBase. So if you are interested in having a REST API, just search for Cloudera and REST. You will actually be able to use the API. See over here. I think I've shown this article to you earlier, but if no, let me show that to you right now. See how to use Apache REST interface and how you will connect to your HBase. So let me scroll down a little bit, and there you see how using a web application you will be connecting to the REST or the Thrift gateway, and everything will be stored in HDFS. Let me copy this, and I'm going to put it into my blog over here. Okay. Let me give a heading, REST interaction with HBase. With HBase. Okay. So this is the way how you can do that. Good. Let me minimize that. Let me have a look at the questions window. Fantastic. Srinivas likes it. He says cool. That's nice. Let me minimize it. So now I needed to have the jar file. So I'll say right click. I'll go down to my build path. I'll go down to my configure build path. And let me say add external jars. And where am I right now? I am in HBase folder. Let me go to HBase, the root of it, and they're actually in the lib folder. In the root there should be 2 jar files. I'm surprised that it's not showing me any jars. I'm personally surprised because I thought there were 2 jars. Anyway, doesn't matter. I'll go down to the lib folder. I will add all the jars from here. Let me scroll down and let me say OK. I'm sure I would need 2 more jars. There is going to be, let me see if HBase is over here. Yeah, I think it is here. So everything is, they have put it into one. I'll say OK. So if there is a issue, we will see it later on. I thought there were 2 jar files at the root. Okay, good. Hey, Praveen said, have you encountered a zombie table in HBase? I created a table customer, somehow I didn't get it created. I did a list and cannot see this table. I again tried to create cus and it says it already exists. I go to Zookeeper, CLI and see the Z node and I see cus there. I deleted the Z node again, but it says cus table already exists. Okay. Okay, cool. So there is there is a article. See, I typically haven't got this thing. The best way how I was able to solve it, that's what Srinivas is saying. He did a restart. Even restart will not help you. So zombie table is where because of a bug. If this bug you will see, Praveen, only if you are using pre 0.96 release. If you are doing 0.98 or if you are doing version 1, you will not get these things. Okay. So the reference I have seen this adnon.me will tell you how to do the zombie table also. That's correct, Praveen. But then this bug has been resolved in the version 1. So if you can try within version 1, you'll be able to see it. Okay. Cool, Praveen. So now I wanted to copy the command. So HBase, let me go ahead and put it in the src location. I will say copy files here. Okay. So HBase connector. That's what I thought. It needed 2 packages. Just give me 1 sec. I'm opening up that file. It's giving, okay, that's because of the package. Let me create a package called as com.edureka new package com.edureka and I will move the HBase file to that particular package. Okay, I have moved it. It's taking some time, as you can see it in the hourglass. Okay, but then it is resolved. So what are we doing? We are creating a HBase configuration. You can see over here, my H table is pointing to the my little HBase table. I am going to add a new record called as my little row, which will have some column name and some value. Then using get, I'm showing you how to get the value. And then using scan, I'm showing you how to get all the values. Okay. So that is what is, I'll say found row using scan. Okay, I'll come back again. Found row. Why can't I edit this? That is very surprising. There we go. Found row using scan. Okay. So I'm just saving this. And now if I directly run this, right click. The beauty is you can directly run this. Right click, run as. Come on, Java application. This will actually connect to your server. I know the server is running. Okay. And see over here. See how it is connected to the server. Okay. And you can see over here how it has got some value. See here, found row using scan. It has given me the row, the family, the column name, the timestamp, and the value of it. See, this is the value that we have got it using get. So through programmatically, you will be in a position to actually go ahead and see it. What is the scan class in the connector example? We have already seen scan, right? This one, Anand. See, we did a scan HBase, right? See, this was a scan that I did. So all the commands that we have in the console, scan, get, put, etc., are all available. So if I just say scan, single quotes, my little HBase table, okay, you will see that it will have some value. See, it has got a value called as my little row, and it will have some further value. So this is how programmatically we are showing you how to get connected to the HBase and then try it out. Make sense? So through the Java code we saw how the values are inserted, etc. Fantastic, Ananda. Hey, great, Arvind. Thank you, mate. So this was our hands-on, guys. There is one more example in the VM that you should try it out, guys. So that example is going to be, if you look at, there is something called as HBase test. So in this, what are we doing is I have actually created separate methods for create table, delete table, adding one record using put, then deleting one record, then getting one record, that is get, then getting all records, that is scan. Okay, and then programmatically we are showing you how we can add records and delete things. So this is something that I want you to try it out, guys. Okay, this is there for you in your LMS folder, so please try it out. Just to make you clear, Zookeeper is one of the ecosystems of Hadoop, which is very popular in the fact that it takes care of coordinating. It is a naming registry. It is a synchronization service that you can use in your enterprise products. So let's go ahead and go to Google and find out what is Zookeeper. So let me simply go ahead and search for Apache Zookeeper, and if you see that, it will take you to the home page, and you would see that Zookeeper is an effort that was done by Yahoo to develop and maintain an open source server which enables highly reliable distributed coordination. See, the problem with distributed computing is multifold. You will have multiple processors running. You need to have synchronization between those processors. You need to coordinate between the processors. So trying to write something from scratch is pretty painful. So that is the reason why the guys in Yahoo had developed these things. So see over here, Zookeeper is a centralized service for maintaining all of your configuration, that is your XML files, information, configuration information, naming, and provide distributed synchronization and providing group service. All of these kinds of services are used in some form or the other in a distributed application. Each time they're implemented in a lot of different ways, so that fixing bugs and trying to reduce the race conditions would be very difficult. Because of the difficulty in implementing these kind of services, applications initially usually make limited use of them, which makes them brittle in the presence of change. So that is why the concept of Zookeeper came about. Okay, so you can see over here it's an open source volunteer project from the ASF, Apache Software Foundation. Let me just quickly kick off my VM so that it will be ready by the time when we want it. So I'm going to go down to VMware Workstation, just a couple of seconds. I'll kick off my VM and then we will start with the theory part of it. So let me go ahead to my Edureka VM and come on. Let me double click on that so that it should come up. There it comes, and let me power on the VM and it should show you starting. Yep, there we go. It gets started. Let me minimize it and let me come back. Okay, so let's go back to the slide. So if you look at why is use Zookeeper, Zookeeper is used to solve complex distributed algorithms. It will give you a way by which you can easily do consensus and a lot of additional functionalities that is there. It has got inbuilt logic for distributed coordination so that I don't have to write it. Second, Zookeeper is to avoid race conditions and deadlocks, so that in a distributed computing, if one component is waiting for a lock from the other and the other is also waiting for a release of lock from the first, that is what is called as a deadlock. So your proper coordination between the components will ensure that there is no deadlock. It will avoid management complexities, because if you have got multiple distributed applications and if you use different ways of coordinating it, at runtime, the support guys would have a lot of pain because they need to support the application, right? So some kind of a standardization is required, and that's what people use Zookeeper for. It is an easy to use programming model. It's typically a admin role, so that's the reason why we will not have a hands-on for this, because it's primarily an administrator kind of a role, and you can apply the reusable code libraries in common use cases. So that is the reason why we should use Zookeeper. And a quick look at who is using Zookeeper. So if you go back to, again, our Google and search for Zookeeper powered by, like Hadoop powered by, you will come to know who is using Zookeeper, and I'll take you to the Apache wiki wherein it will have the details. Exactly. The Zookeeper will maintain, in Gen 2, Zookeeper maintains an information about active and passive name node. It doesn't maintain information about data nodes. It depends upon how you configure it, Srinivas. So see over here, Android Logic is using Zookeeper to implement the clustering support. Whenever you're talking about multi-node, etc., that's where Zookeeper comes in. Deep Dive is using Zookeeper to manage the server state, control index deployment. Within Eclipse itself, Zookeeper is used. Kata uses Zookeeper for node manage, master and index management. HBase uses Zookeeper for selecting the master, understanding what is the lease of your server, bootstrapping and coordination between servers. Neo4j uses Zookeeper. Rackspace, which is a cloud-based provider like Amazon EMR, uses Zookeeper to give distributed locking for connections to prevent clusters from overwhelming servers. Yahoo uses Zookeeper for a lot of things like leader selection, election, configuration management, sharding, etc. Solar, which is a search engine, uses Zookeeper, and even Makara is using Zookeeper. They're looking at a 100-node cluster right now. So this is a publicly known figure, but then this is just 1% of what people are actually using it. Okay, cool. So if you look at what is the target market for Zookeeper, wherever there is multiple hosts, multi-processing and Java-based system, Zookeeper is going to be used. Okay, so typically if you look at who's going to use Zookeeper, so anywhere wherever multi-host, multi-processors and clustering kind of a thing. So you might know that even in WebLogic and WebSphere, that is Java application servers, there are clusterings that is there. In such cases, Zookeeper is going to be used, folks. That's correct. That's correct. Multiprocessing, multi-process clustering, multiprocesses is what I meant. Okay. So whenever you're talking about multiprocess computing is what I meant by C over here. So now, if you look at the data model of Zookeeper, Zookeeper has got a hierarchical namespace like a file system wherein it will have the details of everybody who's connected to it, like every node will have data and children, and everything is written, read and written in its entirety. That means it is completely written. So to understand what is this, I think again, if you go down to just search for, hey, what I would want is, see, the beauty of open source is whenever you download something, so you will get in the doc the complete wiki. So let me go down to my softwares. I think I have got it in my customers. Give me one sec. I have downloaded Zookeeper. Sorry. Let me go down to Edureka. Let me go down to my 10-week schedule. Let me go down to week 9. And I think I have got, where is my Zookeeper? Okay, just give me one sec. Too many things on my plate right now. Hey, there we go. So see over here, I have downloaded Zookeeper. What am I trying to show you is I'm trying to make your life easy by telling you how to go ahead and understand what is Zookeeper. Okay? So if you look at Zookeeper 3.4.5, and if you look at the docs, in the docs, if you open up any of the page like index.html, you would see that you will see the documentation of the API, and this is what I wanted to show you. So you can see I'm looking at it locally. So you can download any of the ecosystem components. You already have the ecosystem components in your VM. You can move that to your local machine, and I mean Windows machine, and have a look at it. Or of course you can look at it from your Windows machine also, your VM also, but I'm just opening it up over here. So see over here, Zookeeper is needed because distributed computing, doing coordination in a distributed computing is a zoo. Zookeeper is a high-performing coordination service for distributed application. It exposes common services that is always used in a distributed computing, like naming, configuration management, synchronization, in a simple interface so that you don't have to use it in a scratch. So let me look at the overview of the Zookeeper. So if you look at Zookeeper, you will see Zookeeper is simple. Why? Because it allows the processes to coordinate with each other through a shared hierarchical namespace. This is what I wanted to show you so that it will become clear to you. This is what we had seen it on the screen also. Okay, so that's the reason I opened up this page. So it has got a namespace called as Z nodes that is similar to files and directories. The Zookeeper implementation puts a premium on high performance, highly available, strictly ordered access. So it gives you some guarantees. I'll have a look at what are the guarantees that it gives you. The performance aspect of Zookeeper means it can be used in a large distributed system. So let me first show you what is the guarantee that it gives you. These are the guarantees what Zookeeper is going to give you, and let me copy this because this is the most important thing. Let me open up a document for you guys. Give me one sec. Let me open up another page. Go down to Edureka. Come on, customers. Edureka. I'll go down to Venkat session, Feb 21st, and this is going to be day 11.txt. Let me open up a document called as day 11. And in this I'm going to paste this, and you know that I'll always upload this like what I've been doing until now. I'll do a word wrap. So this is the guarantees. It gives you sequential consistency, so whenever you are having updates coming in from multiple systems, update from clients will be applied in the order in which they were sent. So sequential consistency is very important. It will give you the atomicity benefit. Either everything will succeed or it will roll back. No partial results. It will give you a single system image so that the client, irrespective of whatever node he connects to, he will see the same view. It will give you reliability. Once an update has been updated, it will be there always till the time the client overwrites it, and it will give you a client's view of the system is guaranteed to be updated within a time bound. So it will give you the timeliness view of it. So what do you actually mean by all of these things is shown to you beautifully in this diagram. This diagram, even we are having it in our slide. So first let me show this diagram to you. So Zookeeper is like a coordination server. So anybody who wants to make a change, it's like a lookup. I'm sure all of you working in your organizations will have a help center, which is if you are a global organization, you will have it 24/7. So this is what is called as typically following the sun. It will start with Japan, then it will go to Australia, then it will go down to India, then it will go down to Middle East, it will go down to Europe, it will finally wind up with the East Coast and then the West Coast of US. And then again, by the time the West Coast goes down, Australia is already up. It's an exact 12-hour difference between the West Coast and the Australian time zone. Okay, so what happens is you will have servers in multiple locations, and there will be different clients who will be connecting to it. So Zookeeper typically is going to be replicated. So like the distributed processes it coordinates, Zookeeper is intended to be replicated over a set of machines that is called as an ensemble. So please remember, ensemble is like a cluster. So typically it will be 3, 5, 7 kind of a cluster, so that whenever Zookeeper starts, one of them would be selected as a server, leader. So the leader is a guy through whom all updates will go, and all the others will be serving the clients. So if anybody makes a change in any one of the servers, the update will have to go to the leader. The leader will propagate that change across to all the different servers, so that next time a client looks at it from any other location, he would see the single view of it. Exactly. So a kind of a master lead, that's correct. So it's a kind of a master server kind of a thing, wherein the beauty is it gives you all of the benefits like I have told you earlier. It is simple, it is replicated, it is ordered, and most important, it is fast. Okay, so this is what I wanted to show you, but I also have given you an idea about what all are the things what you can see over here. See, it gives you a lot of benefits. If you look at the developer page, there is recipes, there's a programming guide, admin and operations would have a lot of other things also. So have a look at these documentation. These are invaluable. Hey, there comes the slide what I just explained to you right now. So Vinit was asking, these servers are different from the region servers. I mean, these servers in Zookeeper will not contain val. No, my dear friend, it's completely different. Let me diagrammatically show you in the case of an HBase. So if you talk about HBase multi-node installation, so this is what you'll be having. You will have one machine where there will be a name node, another machine where there will be a job tracker, resource manager, another machine where there would be, let's call it as active name node. Then you will have something called as passive name node. I'm talking about masters, resource manager, and then you will have HMaster1, you will have HMaster2. Then you will have a separate set of machines where there is Zookeeper ZK1, ZK2, ZK3. Then you will have data nodes where you are, slaves, where these are all going to be masters. Okay, these are all going to be masters. So you will have slaves. Okay, in the slaves you will have your data node service running, you will have your node manager service running, and you will have your region server service running, depending upon whether you wanted the region servers to be there on all the nodes. This is what is going to be the architecture debug. Application master is not a daemon. It is going to be running on the node in a container. So application master is not a daemon, Srinivas. 357 is, typically it has to be a odd number depending upon how you are having a data center, so that if when one of them start, it will be easier to find a leader. That is why it is 357, Vijay. So in a distributed computing, what were the wishes what people had? They wanted a wait-free kind of a service, simple, robust, good performance service, tuned for read-dominant workloads. The model should be familiar. It should not be something that is completely new where I have to do the learning curve again, and it should be able to wait efficiently. And all of these things, wishes, are provided by Zookeeper. I have shown it to you on the wiki page. So now if you look at Zookeeper and HBase, so the master failover in HBase, remember I told you about HMaster1 and HMaster2, that is taken care of by the Zookeeper. The region server and the master discovery is via the Zookeeper. So HBase clients will always communicate with the Zookeeper to get the configuration information about where is the details of my region server and regions. So that configuration information would be there in Zookeeper. Now understood what is Zookeeper, because Zookeeper is going to act like a project lead over here in our example, and the region server and master failover detection is also handled by the Zookeeper, because he keeps a contact of all the different systems what is there in the complete environment. So remember I have told you about the root region server IPs when we did our HBase. So master, if there are more than one master, which will always the case, they will fight so that there will be one master. So that's the reason why 357. The root region server is going to be the Z node, or the system that holds the location of the server hosting the root of all tables in HBase. A directory in which there is a Z node is based for every region server. Whenever the region server comes online, they register themselves with the Zookeeper, so that the region server failures would be done by the Zookeeper, so that if a machine fails, if a slave fails where the region server is there, then the master can do sharding. It will split the val, that is write ahead log, across multiple regions. That is the way how this architecture is going to be. So if you look at version 3.3.0, let me go down to the Zookeeper page, and let me just search for, let me go back to the earlier page. And if you see over here in the releases, 3.4.6 is the stable release and 3.3.6 is the stable release. So we are talking about what is there in 3.3 and 3.4. Hey, Krishnamurthy was asking me, can you give me an example of the type of projects requiring Zookeeper, what extra effort we need to consider, whether the underlying HBase Pig no Zookeeper is in place. Krishna, you need Zookeeper only when you need a multi-node HBase cluster. If you're talking about Hadoop, you don't even need to know about Zookeeper because Zookeeper is implicitly used. Zookeeper needs to be explicitly configured only if you're having a multi-node HBase cluster. That is it. Point. Got it, buddy? Don't get confused, Krishna. It's pretty simple, and I'm trying to keep it that way for you, Krishna. So now let's move on. So in 3.3.6 we had Zookeeper giving you a configuration for the session timeouts. It gave you a lot of improved logging information. It gave you a lot of improved debugging tools. The documentation was good. Performance was good. And something called as, you know what is a queue and topic. This is in messaging service. So it started giving you queue implementations also. So that was in the previous release, 3.3.0. And in 3.3.4, that is the latest release. Yeah, that's right, Srinivas, I mean JMS. In 3.3.4, we had seen our lot of additional enhancements in the form of documentation. So now please practice the advanced HBase codes that you have in your LMS.